Hello and welcome. My name is Brian Chu. I'm a Microsoft technical trainer. I'm here to walk you through the AZ-800 Administering Windows Server Hybrid Core Infrastructure course. Let's get started. In this session, we will focus on implementing a hybrid file server infrastructure. We'll cover an overview of Azure File Services and dive into Azure File Sync, including a lab at the end of this session. Let's begin with an overview of Azure File Services. Azure File Services provide scalable, secure, and flexible storage solutions in the cloud, make it easy to integrate with your existing environment. Azure offers four main types of storage services. Blobs for unstructured files supporting exclusive file access for VM disks. Tables for unrelational semi-structured data. Queues for temporary message storage, enabling asynchronous communication. And files for unstructured data, supporting serverless deployment, redundancy, encryption, and granular permissions. Azure Files can be accessed from anywhere, integrates with existing environments, and supports previous versions and backups. Azure Files can be deployed using different storage account types. Locally redundant, LRS. Zone redundant, ZRS. Geo-redundant, GRS. Geographically zone redundant, GZRS. Read access geo-redundant, RAGRS. There are two storage tiers, Premium and Standard. Common uses include replacing on-prem file servers, lift and shift migrations, backup, disaster recovery, and Azure File Sync. Access to Azure Files requires authentication. You can use identity-based authentication over SMB, access key, shared access signature, SAS, and Microsoft Entra Kerberos for hybrid identities. In the diagram on this slide, we can see that when a user accesses Azure Files, authentication is handled by Microsoft Entra Domain Services, or ADDS, which issues a Kerberos token for authentication. Azure provides several RBAC roles for identity-based access. All data in Azure storage accounts is encrypted at rest using Storage Service Encryption, SSE. You can use Microsoft Magic Keys or bring your own. And encrypt in transit is enabled by default. To create an Azure file share, first, in the Azure portal, select your storage account. Next, enter File Service, select File Shares. Click File Share. And finally, enter the name and quota, and then click Create. This process makes it easy to set up scalable file storage in Azure. By default, storage account firewalls allow access from all Azure VNets and the public internet. You can configure firewalls for trusted Azure services and set up private endpoints for secure access. To use an Azure file share, mount it as a drive or access it via UNC path, which includes the stored account name, domain suffix, and share name. Azure Files supports share-level snapshots, up to 200 per share. Snapshots are incremental and useful for protecting against accidental deletions or changes, general backup purposes. Snapshots help you quickly restore previous versions of your data. Now, let's move on to Azure File Sync. Azure File Sync allows you to centralize your file shares in Azure while keeping the flexibility and performance of on-prem servers. Azure File Sync offers several benefits. Multi-site sync with multi-master replication. Optional cloud tiering to optimize local storage. Cloud backup using Azure Backup. Fast disaster recovery by quickly restoring folder structures and files. These features make Azure File Sync a powerful tool for hybrid environments. Azure File Sync caches Azure file shares on-prem. With cloud tiering, your server always has free space, and the files are presented as if they are local, even if some are stored in Azure. If a user accesses a tiered file, it's transparently downloaded from Azure. File Sync supports multi-master sync between multiple servers, ensuring data consistency across your organization. Let's recap the main components of Azure File Sync. Storage Sync Service, the top-level Azure resource for managing file sync. Sync Group defines which files and endpoints are kept in sync. Registered Server represents a trusted Windows server or cluster connected to storage sync services. Azure File Sync Agent, the downloadable package that can enable syncing. Server Endpoint, a specific folder or volume on your Windows server. And last, Cloud Endpoint, an Azure file share that's part of a sync group. Understanding these components helps you design and manage your hybrid file sync topology. To implement Azure File Sync, follow these steps. For manual step, deploy the storage sync service. Install the Azure File Sync Agent. Register your server. Create a sync group and add server endpoints. From Windows Admin Center, connect your server. Set up Azure File Sync. Deploy the agent. Register with the sync group and select folders to sync. Both methods make it easy to centralize and synchronize your file data between on-prem and Azure. Cloud tiering helps optimize local storage by automatically moving less used files to Azure. There are two main policies. Volume free space policy, always keep a specified percentage of free space on your server volume. Date policy, only cached files locally that were accessed or modified within a set of number of days. Cloud tiering ensures your servers have enough space and that frequently accessed files are always available. How can you recognize tiered files? Tiered files don't use local disk space. Their size on disk is 0 bytes. They have attributes like offline, reparse point, and recall under the access. You can check for a reparse point using fsutil reparse point query command. You can manually tier or recall files and use the invoke storage sync file recall cmdelete to recall multiple files at once. Windows Server supports DFS namespaces and DFS replication. Azure File Sync is compatible with both, and you can run File Sync and DFSR side by side during migration. If you use both, disable cloud tiering on DFSR volumes and avoid configuring read-only DFSR folders as server endpoints. To migrate from DFSR to Azure File Sync, first, create an Azure storage account, file share, and storage sync service. 2. Create a sync group that matches your DFSR topology. 3. Install the file sync agent on your DFSR server. 4. Register the server and create the first server endpoint. Don't enable cloud tiering yet. And 5. Wait for all data to be synced to Azure. Let's continue with migration process. Install and register the file sync agent on each remaining DFSR server. Disable DFSR. Create server endpoints on each DFSR server without cloud tiering. Ensure sync completes and test your setup. Retire DFSR, then enable cloud tiering as needed. Now, it's time to put your knowledge into practice. Lab 10 will guide you through implementing Azure File Sync, reinforcing the concepts and skills you have learned in this module. You'll test Azure File Sync as an alternative replication mechanism between two on-prem file shares. In this lab, we will implement Azure File Sync. First, we will implement DFS replication on-prem. We will first deploy DFS in SCA Admin 1. To do that, we will use install Windows feature PowerShell command. So let's launch Windows PowerShell first. And we will run the command to install the feature and the relevant management tools. After the Windows feature is available, we will deploy DFS from PowerShell command. Okay, as you can see, the installation is successful. So next, we will launch Windows File Explorer. And let's navigate to lab files and lab 10. So let's right-click, deploy DFS PowerShell. And let's edit. So this will launch Windows PowerShell ISE. So you can take a closer look at the details within this PowerShell. As you can see, the paths will exist on SCA SVR1 and SCA SVR2. So it will also create a DFS replication group called branch 1. Okay, so now we can run the PowerShell script. Okay. Now the setup is complete. Next, we can test the DFS deployment. So we will minimize this PowerShell ISE. And we will use the DFS management tools we just installed. So from the Start menu, I will input DFS. And let's launch the DFS management tool. So first, we need to add the DFS namespaces. So we click namespaces, and we can choose Add namespaces to display. As we can see, the namespaces is already listed here. Let's click OK. And on these namespaces, there should be a folder called data, right? And the data folder actually exists on both SVR1 and SVR2 as what was shown in the PowerShell script. So to verify that, let's click Replication. And then we click Add Replication Group to display. So we'll select branch 1. And then we click OK. So as you can see, the data folder exists on both SVR1 and SVR2, which indicate our DFS deployment is successful. For the next step, we will create a sync group. Let's open File Explorer again. To do that, we can try to get access to the data folder right from SCA admin1 server. Okay? As you can see, it is successful. We can also test the connection to SVR2. So we will keep these two windows open for later demonstration. As you can see, there is no data within both of the folder right now. So what we will do is we will create a new file. So let's call this file demo. And we add some contents within the demo. So this one is for SCA SVR1. And if we switch to next network folder, you will see that the demo file is already replicated to SVR2 server. All looks good. Now let's switch gear to the Azure portal. And first, let's create an Azure file share. To do that, we need to have a storage count. So first, let's create a new resource group. And we need to pick a unique storage count name. So let's call it AZ-800 demo lab 10. For the redundancy setting, we will choose locally redundant storage because this is for our demonstration only. But in the production environment, you need to select according to your specific data redundancy requirement. All right. Let's click the Create button. Okay, so the storage account is available. Next, we will create an Azure file share within the storage account. So here we click File Shares, and we create a new file share. So we will name the file share Share1 and click Review and Create. Okay, so let's switch to the Backup tab. And as we can see here, by default, backup is enabled. So let's uncheck the box and try to create the storage account again. All right, so the file share is created. What you can do with the file share is you can now upload file into it. So let's click Browse. And then we can choose Upload. So here, we will select file 1 from the local machine and drag it into the file upload window, and then get it uploaded into Azure File Share. You can also add file share snapshots. So now let's do a test for that. So from here, we choose snapshots, and we can click Add Snapshots. So this will create a snapshot for this file on the specific timestamp. Later on, we can do the restore to this specific timestamp. Okay, so for the next step, we will connect to this file share from our local server. So we click the connect button. And we will click show script. And we can copy the script. And then we paste it into the Windows PowerShell ISE. And let's create a new tab. So let's paste the script here. And we can run the script locally to connect to the file share. All right. After we run the script, you will see that now the file share is connected locally as drive Z. So let's switch to the File Explorer. And we click Share 1. As you can see, this is the file we just uploaded into the Azure file share. So let's make sure that there is no previous version for the file locally stored. All right, and then we can modify the file, right? And then we can take a look at the previous versions to see whether existing previous versions can be restored. Okay, so doing this, you can restore the file to a previous version locally. So let's do an edit. We can see that this is the previous version without any modification. Okay, let's add demo to the file. And this time, let's click Properties of the file. And from previous versions, you can see that there is a previous version that you can restore to. You can click Restore to the original status of the file 1. You can also do this restore from the Azure portal. Next step, we will set up a file sync group. So let's close this one. And let's take a look at the file sync. And we will first create an Azure file sync from the Azure portal. We first select the resource group, and then we give a name for the storage sync service. And let's review and create. So this will create the file sync service in Azure. And next, we will install the Azure File Sync agent on the local server. Okay, The deployment is successful. And let's continue with the setup. Let's click Sync. And we create a new sync group. And we call it this one Sync1. And we select the previous storage account we created. And we also select the Azure file share we created. And we will set up this sync group. And next, we will add sync servers within this sync group called Sync1. So let's click Register Servers. So as we can see, there are no servers registered within Azure File Sync yet. So what we need to do now is we need to install the Azure File Sync agent. You can first download the File Sync agent. Here, you can see that it has several Windows Server versions supported. So here we will get File Sync agent installed. So we will select the agent that is corresponding to our current operating system version and click Download. Okay, so the agent is downloaded, and we will copy the agent into our lab folder. Because this time we will do an automated installation for the sync agent. So this is the way when there are many sync servers to be registered with the Azure Sync service. So let's first take a look at the automation script. So as you can see in the script, it will indicate the local server name and the resource group and the file sync name. All right, and then it will copy the installation agent locally to the server and run the installation. So here we will run the automation script to get the Azure File Sync agent installed. During the installation, you will be pop up for the authentication in Azure. All right, so here you need to copy the link and open it in a new browser tab. And then you use the code listed here for authentication. So let's launch a new browser window. And then we will use the code to log into the Azure platform. We will select the lab user to do the authentication. All set. We can safely close this browser window and continue with the installation of the Azure Sync agent. All right, so the script is finished. And as you can see, this will register the server in Azure File Sync. So let's take a look. So what we'll do is we will refresh the page. And as you can see, the SEA SVR1 server is online. After the local server is registered in Azure File Sync, what we can do next is we can add it into the sync group. So let's click Sync Groups. And then select Sync 1. We have already added the cloud endpoint that is related to the file share we created earlier. So here we add the local server with Azure Sync Agent installed. And then we will set up a path for the file sync. So we will set this one as S drive data and click Create. Okay, so as you can see, the server is registered. And we can take a look at local folder to verify the synchronization. So if we switch to the data folder, we can see the file 1 previously uploaded to Azure File Share is already synced locally with the Azure File Sync. This concludes our session. In this session, we explored how to implement and manage hybrid file server infrastructures using Azure Files and Azure File Sync, enabling secure, scalable, and flexible storage solutions that seamlessly integrate on-prem environments with the cloud. There are many ways to continue your learning journey. We encourage you to watch other videos in this course, or search out your next favorite topic on Microsoft Learn at aka.ms/learn.